Your brain learns from experience. And, well, neural networks try to do the exact same thing. At its very core, that's really the big idea here. You see, we're not talking about programming a computer with strict, rigid rules for every single thing it might encounter. Instead, we're building systems that are inspired by that incredible web of neurons inside our own heads. We're creating systems that can actually learn to spot complex patterns all on their own, just by looking at data. So how do we get computers to think a little more like us? In this explainer, we're going to really unpack what neural networks are, why they're the engine behind so much of today's AI, and how they're already a huge part of your daily life. This is AI Tech Cheat Code, your shortcut to understanding technology. So let's break this down step by step. Okay, so to really get why neural networks are such a game changer, we first have to understand the problem they were built to solve. You see, before they became popular, we have to rely on much simpler models, and those models had one pretty major weakness. For a long time, machine learning often used something called linear models. And for simple problems, they work great. I mean, imagine you have two groups of data, right? We've got our blue dots and our orange dots here. If the pattern is nice and simple, you can just draw a single straight line to separate them perfectly. The model's job is just to find the best place to draw that line, and voila, it can accurately classify anything new. It's clean, simple, and for a while, it was enough. But what happens when the world isn't so simple? Take a look at this. Now the blue dots are all clustered in the middle, and the orange dots are in a ring all around them. This is what's called a nonlinear problem. Go ahead, try to draw one single straight line that can separate these two groups. You just can't do it. No matter where you put that line, you're always going to have a mix of blue and orange on both sides. This is where those old linear models just completely fall apart. The real world is messy. It's full of complicated patterns, and a simple straight line, well, it just can't keep up. And that leads us to the big question. If a straight line isn't going to cut it, what do we do? How on earth can we teach a machine to see these really intricate, complex shapes and relationships without us having to go in and manually write code for every single possible curve and corner? This exact question is what sparked the whole idea of neural networks. And the answer, funny enough, came from looking at the most powerful pattern recognition machine we know of, the human brain. The whole core idea behind neural networks is to build a computer system that's structured in a way that's inspired by how our own brains work. So what is a neural network, really? Well, you can think of it as a system made up of tons of simple, connected processing units. We call them nodes or artificial neurons. These nodes are all organized into layers, and they work together as a team to automatically find those tricky, non-linear patterns in data. The whole point is to create a system that can adapt and learn from experience, getting better and better over time without a person needing to constantly jump in and tweak the rules. Now, what's so cool about this is how simple the basic structure is. At its most basic, a network has three kinds of layers. First up, you have the input layer. This is where the raw data, like an image or text, comes into the system, kind of like the network's eyes and ears. Then you've got one or more hidden layers. This is where the real magic happens, the heavy lifting. Each layer in here is responsible for finding patterns that get more and more complex. And finally, you have the output layer, which spits out the final result, a prediction, a decision, you name it. It's like a super specialized assembly line just for processing information. All right, let's zoom way in and look at just one of those little nodes. An artificial neuron is basically a tiny piece of software with a very simple job. It gets signals from other nodes before it, it does a quick bit of math on them, and then it decides if the signal it creates is strong enough to pass on to the next layer of nodes. One neuron by itself isn't all that smart, but when you connect thousands or even millions of them together, that's when they can start to represent incredibly complex ideas. Okay, so having a structure that looks like a brain is cool and all, but the real power, the secret sauce, comes from the network's ability to learn. A neural network isn't built and then just left alone. It's designed to adapt and get smarter by learning from its own mistakes. And that happens during what we call the training process. So how does it actually learn? Well, it's this really clever four-step loop. First, in what's called the forward pass, you show the network some data and it makes a guess. Step 2, you calculate the loss. That's just a fancy word for a score that measures how wrong the guess was. The bigger the mistake, the higher the loss score. Now, step 3 is the most important part of all, backpropagation. The network takes that error score and sends a signal backward through its layers. Imagine you're playing a game of telephone, but in reverse. The person at the end of the line knows the final message is wrong, so they whisper back to the person before them, telling them which part they messed up. That person tells the one before them, and so on all the way back to the start. Backpropagation is the network telling itself, layer by layer, exactly which connections were most responsible for the mistake. And finally, step 4. You repeat this whole process millions of times, making tiny, tiny adjustments with every single cycle to get better and better.
And what is the network actually adjusting during this whole backpropagation thing? It's fine-tuning millions of little numbers called weights. You can think of a weight like a volume knob on the connection between two nodes. It represents the strength and importance of that connection. When the network learns, it's essentially turning up the volume on connections that led to the right answers and turning down the volume on the ones that led to mistakes. So really, the whole process of learning is just a massive search for the perfect set of volume knob settings to solve a problem.
And this is the amazing result. Remember that complicated circular data that a straight line couldn't handle? Well, as the network trains, watch what happens to the decision boundary. That's the line separating the colors. It starts out as a simple, pretty useless line, but with every single loop, backpropagation gives the weights a little nudge, and the boundary starts to bend and curve and warp until it perfectly wraps around the blue dots, cleanly separating them from the orange ones. It has learned the complex solution all by itself. It's a pretty incredible process when you see it happen. If this is making sense so far, do me a favor and give the video a quick like. Now, this might sound simple, but honestly, this is where most beginners get their minds blown. The idea that millions of tiny independent adjustments can add up to such intelligent-seeming behavior is what makes this whole field so powerful and, yeah, a little bit trippy. Okay, now that we've got the theory down, let's talk about where this stuff actually shows up in the real world. Because the truth is, you're already interacting with neural networks every single day, probably without even thinking about it. These are some of the biggest areas where neural networks are absolutely dominant. They're the power behind computer vision, which lets machines see and understand the world. They run natural language processing, helping computers make sense of our words. They are the brains behind those recommendation engines that tell you what to watch or buy next. And they're making huge breakthroughs in really important fields like medicine and finance. Let's start with computer vision. Anytime you unlock your phone with your face, or you see a video of a self-driving car identifying a stop sign, you're looking at a special kind of neural network called a convolutional neural network, or CNN for short. They work by sliding a little virtual magnifying glass over an image, piece by piece. This little window is looking for really basic features, like an edge, a corner, or a patch of a certain color. As you can see here, the first layers find these simple things. The next layers combine them into more complex shapes and textures. And the final layers put all those pieces together to recognize whole objects, like a person, a car, or a cat. Then there's natural language processing, or NLP. This is all about teaching machines to get the subtleties of human language. When you ask a virtual assistant like Alexa or Siri a question, it's a neural network that's frantically working to figure out what you actually mean. It's the tech that powers those amazing real-time translation apps, and it's what's behind those chatbots that can now hold a surprisingly good conversation. And, of course, recommendation engines. You know them well. Platforms like Netflix, YouTube, Spotify, and Amazon, they all use neural networks to analyze what you watch, listen to, and buy. They track your activity to find these really subtle patterns, connecting what you like to what other people similar to you also like. This lets them suggest new stuff with sometimes scary accuracy, keeping you hooked and helping you discover things you never would have found on your own. Okay, so neural networks can seem almost like magic. But to really, truly understand them, it's just as important to know where things can go sideways. There are a few really common traps that beginners, and hey, even some experts, can fall right into. Here are 3 of the biggest ones to watch out for. First is the idea that bigger is always better, that you can just keep adding more and more layers and your results will magically improve. The second is forgetting the absolute golden rule of machine learning. Garbage in, garbage out. A neural network is only ever going to be as good as the data you feed it. And the third, which is probably the most critical concept to get, is a nasty problem called overfitting. Let's really dig into overfitting. Think about a student studying for a big exam. A good student tries to understand the actual concepts. They learn the why behind the answers, so they can tackle new questions they've never seen before. That's a good fit model. Now, an overfitted model is like a student who has just perfectly memorized every single question and answer from the practice test. They'll ace that practice test, no doubt, but the second they get to the real exam with slightly different questions, they're toast. They totally fail. The model didn't learn the general pattern. It just memorized the training data, including all its little quirks and random noise. And that's exactly why we always keep a separate test data set that the model never ever gets to see during training, so we can get a real sense of how it'll do out in the wild. All right, so let's tie this all together with a quick recap. What are the most important things to remember? First, At their heart, neural networks are inspired by the human brain and are built to find complex patterns. Second, and this is key, they learn from data. They are not programmed with a bunch of fixed, handwritten rules. Third, that whole structure of layers and adjustable weights is what makes the learning happen. Fourth, training is a powerful feedback loop. Guess, check your mistake, adjust, and do it all over again, millions of times. And finally, remember that these aren't just some lab experiment. They are the engine that powers most of the modern AI systems you use every single day.
In our next explainer, we're going to build right on top of this and dive into deep learning. We've talked about networks having hidden layers, right? Well, deep learning is what happens when you use lots of hidden layers to solve even more mind-bogglingly complex problems. It takes everything we've talked about today and cranks it up to 11. If you like this content and you learned something from us, please subscribe to this channel for more updates like this video and share this video on all your social networks.